Alright, so y'all go ahead and do the factoring and the math knowledge question for today. Pause the video, and then once everyone is finished, you can unpause the video and I'll go over the correct answers. So for the factoring, we're going to take the 5 and remove it by multiplying it by the 2 to make it 10, and then you're going to have 5x minus 5 and 5x minus 2. The first one will reduce, and the second one will stay as is. And so that'll be your answer for the factoring. For the math knowledge question, we have a triangle. We have A, B, and C. And A and C are congruent, and B is 114. So A plus C plus 114 is 180, but A and C are the same thing. So if you subtract 114 from 180, and divide by 2, A equals 33. And so that would be your answer. We are looking at lesson 37 today, differentiation by use substitution. So we have looked at differentiation already, but now we're going to be looking at ones that are a little bit more complex. So we're going to learn how to use substitution. So hopefully after the lesson you'll understand how this works. It's very important to be able to look at a complicated expression and recognize the basic form of the expression. That's what we're going to need to know how to do so that we can do use substitution. The basic form is often going to suggest the substitution that should be used. So in this lesson we're going to use the letter U to write the basic form, and the substitution is called use substitution. So that's where the name comes from, because we use the letter U for our substitution. So y equals e to the x squared plus 2 has the form of y equals e to the u. So we would replace the x squared plus 2 with a u. Okay, let's look at another one. Y equals x cubed minus 2x squared plus 1 to the 100. Anyone have an idea as to what it has the form of? Y equals u to 100. Okay. Y equals the ln of x squared plus 42. That has the form of y equals the ln of u. Looking at another one, y equals the sine of x squared minus 15. It has the form of sine of u. Trying another one, y equals sine of x cubed. It has the form of y equals u cubed. So hopefully you kind of see a pattern there. You're trying to make your equation as simple as possible with your u substitution. So we're going to look at an example. The first thing you need to figure out is what is our u going to be. So this has the form of u to the 10. And our u is x squared plus 2x. So we're going to put a little box, and we're going to have a line that goes underneath the u. And that line is going to be the du. So the differential of u is du. The differential of x squared plus 2x is 2x plus 2 dx, because those are with respect to x. So over here, when we take the derivative, we're going to have 10u to the 9th, and we need to make sure that we take the derivative of our u, so du. So that's the differential that we're going to use, differentiation with u substitution. And so now we just need to plug in our u and our du. So we're going to have 10. Our u is x squared plus 2x to the 9th, and our du is 2x plus 2 dx. Now, we don't need the dx because we're just looking for the derivative. So our actual answer doesn't have this dx on there. The way that you could fix that, if you don't like having to erase it, you can make this over here, instead of it being f and f prime, you could make it y and dy. So then dy divided by dx would equal this. And so instead of erasing the dx, you would just divide by it. So that's how you would do u substitution. So let's look at another one. First off, you need to figure out how we're going to replace it with a u. Where would our u be? So y'all have any guesses as to what your u should become for this one? You're going to want to make it the cube root of u, so that your u is x squared plus 2x. Again, we're going to put that in a box so we don't lose it. And then your du would be 2x plus 2 dx. From there, we're going to say y equals u to the 1/3, and then we're going to take the derivative of our equation. So the derivative of y is 1 with respect to y. dy makes it a differential. And then derivative of u to the 1/3 is 1/3 u to the negative 2/3. And then if you put the du, that makes it the differential. So dy is going to equal 1/3. U is x squared plus 2x to the negative 2/3. And then du is 2x plus 2 dx. And so to find your derivative, we're going to move this dx over here. And so this would be your derivative. Okay, looking at the next example, we want to find the derivative of the natural log of x squared minus 42. So what would you let your u be? Hopefully you're going to say x squared minus 42. And you're going to say the y equals the ln of u. And so we're going to put a box around this so we don't lose it. And what would your du be? Derivative would be 2x, derivative would be 0, and we need it with respect to x. So now over here, take the differential, dy equals 1 over u du. Then you're going to plug in your u and your du. So 1 over x squared minus 42, and your du is 2x dx. So you're going to divide by dx, and we're going to rewrite it a little bit. So dy over dx equals 2x over x squared minus 42. And so that would be your derivative. Okay, so let's see if y'all can try this one by yourself. Y'all pause the video real quick, and then y'all unpause it once y'all tried it and see if you get it right. So on this one, you're going to want your u, we're going to let it be y, equals, you're going to want your u to be t cubed minus 15. So that means our equation would be the sine of u. So over here, we need to find our du. So what would du equal? Hopefully you put 3t squared dt. So then if you take the differential, you get dy. Derivative of sine is cosine, and then du. So then we're going to say the cosine of t cubed minus 15, and then times 3t squared dt. From there, dy over dt is your derivative, and most of the time I'm going to put the 3t squared in the front. To make that your derivative. Okay, so hopefully you got that one right. If not, we're going to try another one. So again, y'all try and pause the video and see if you can get this one by yourself. and then unpause it, and I'm going to go over it. So for this one, you're going to want your u to be sine all by itself. If you're having trouble, make the sine cubed of x sine of x cubed, and that would help you just a little bit more. So if our u is sine of x, then our du, the differential of sine, is going to be cosine of x dx. So then we say dy equals, oops, I forgot to make it u. Okay, so we have y equals u cubed. So now we have dy equals 3u squared du. From here, you're going to substitute what your u and du are. And then you're going to solve for dy over dx, because that's what it asked for. So that's going to equal 3 sine squared of x cosine of x. And so that would be your answer. If you want to write it as sine of x squared or sine squared of x, either one of those is technically fine. It doesn't really matter to me which way you write it. Okay? So looking at another one. Let's see if you can try this one by yourself. Again, you can unpause the video and we'll go over it after y'all have tried it. So I would let the u be e to the x, so that my equation is y equals cosine of u. So then your du would equal, what is the differential of e to the x? E to the x dx. So now let's take the differential. We have dy. Derivative of cosine is negative sine of u. And then to make it a differential, du. From there, you're going to replace your u and your du. So you're going to have the sine of e to the x, and then you're going to have e to the x dx. So to solve for dy over dx, you're going to have negative e to the x sine of e to the x for your answer. Okay, so that's how that one would work. Looking at another one, again, y'all try this one by yourself and then unpause the video and we can go over it. So I would let the u be e to the x plus 1, so that I have u to the 1/2. And then your du would be e to the x dx. Okay, so take the differential. Dy equals 1/2 u to the negative 1/2 du. Dy would equal 1/2. Our u is e to the x plus 1 to the negative 1/2, and our du is e to the x dx. So divide by dx, divide by dx, and so you get 1/2 e to the x plus 1 to the negative 1/2 for your answer. And they may write it in a slightly different format. That's fine. If they do, you can leave it like this, or you can make it e to the x over 2 times the square root of e to the x plus 1. If you want to write it like that, you can, but you don't have to. So that's how that one works. Okay, so let's look at this one. So y'all can try this one by yourself and then unpause the video and I'll go over it. So for our u, I'm going to let it be cosine. And then du, the derivative of cosine, is negative sine of x. And then dx, because you took the differential. So y would be the ln of the absolute value of u. So dy would equal 1 over u du. Okay? From there, you're going to replace your u and your du. So dy is going to equal 1 over cosine of x, I'm sorry. And then times negative sine of x dx. So we're solving for dx. So I get negative sine of x over cosine of x. And what is sine over cosine? Tangent. So this would be what we're looking for, negative tangent of x. So that's how u substitution works. Some of you may already be feeling like you don't need to do u substitution because you can do it in your head. That's fine. You should understand the basics of how it works, but if you don't want to have to do it for every single problem, you don't have to. That would be okay with me. Alrighty, so on your homework, you do get to omit number 20. That one is developing an identity that we're not dealing with. So make sure to do the other problems tonight for homework so we can go over any questions you have tomorrow.